Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. This video is among the series of research potential. So hopefully this video can help potential student in doing your master and your PhD, and also for helping potential student to do research, because I have listed all the equipments, tools, and everything. You may not miss anything when you are doing your research. Okay, and this is the potential research, because not many people are doing research on stress wave propagation on cylindrical rod and square plate. Okay, so the article is written to help potential students in doing research on stress wave propagation to cylindrical rod and square and solid square. Students can use the article content as guidance to do their research. In this article, a collection of journals taken from Cylindrical. Okay, the author, which is myself, have done analysis on the subject matter. I myself have listed methods, equipment, finite element method, materials, and many more to help students doing their research. Okay, potential student can use this article to discuss with your supervisor uh, what are the contents and what the material that you have in your research institution, and the list that you have, the equipment that you have in your institution. You can use it. The equipment that you do not have in your institution, you may ignore that equipment. Okay, the proof of research gap is reservoir propagation is only 29 result in the research uh, in Cylindrical. Reservoir propagation focusing on cylindrical or square plate. Okay, let me explain what is the meaning by reservoir propagation. Okay, reservoir propagation. You have plate. You have cylindrical plate. You have a square plate. Okay, cylindrical plate. Also, you have a square plate. Okay, both principle applies. Okay, when you put the force directly from impact, okay, impact from projectile, impact from explosion, okay, impact from anything lah, let's say in the car collide accident. Okay, impact from projectile going into this both material, these both kind of material, the propagation will like that, propagate like that. The difference is the geometry. Okay, the geometry meaning that the stress concentration on that edges is high compared to this cylindrical method. This is the difference. Okay. However, this not many people have studied, uh, uh, especially on impact by projectile or impact by explosion. Okay, no, not many people have studied, because uh, to do the experiment is difficult. However, for those research institutions that have the facility to do this experiment, it is a potential to you to do this kind of research. Okay, so this is some of the research background I have taken from all those abstract. Some are studying the stress wave, investigate the formation mechanism of manufacturing defects and non-destructive testing technology. Okay, manufacturing defects. The keyword is manufacturing defects. Approach of joint morphology and degree of anastomus of stress wave, joint matching. Okay, meaning that some application in some application there are two materials joining together. Okay, two materials joined together. This is material A and this is material B. You want to make it connected together. A and B. Different material, different strength, different everything is different. You want to make it connect. How you make it connect? You give force to it, whether by impact or by explosion, meaning that there is true so tremendous force needed to combine. And then what is the stress wave from this combined to this, from this going to this? This is what the challenge you have to endure. And then internal defects on material structure and their distribution could effectively be identified using stress wave characteristic. Internal defect, okay, of course, on this material, on all other material, they have uh, air trapped inside it, okay, bubble of air trapped inside that material. How and also they have crack, okay, they have cracks. How can we detect them? Okay, adding small amount of the carbon nanotube into the face sheet of sandwich structure can improve their thermomechanical responses. Carbon nanotube, if you can put the carbon nanotube inside this structure, and how can we distribute it evenly along the structure is very good. So if you insert the carbon structure only the upper surface, okay, this is the big surface. You put the upper okay, this is the carbon structure. Maybe if we on the upper surface, how can you make it going down? Okay, this is another challenge. Maybe you have to use impact force. Okay, and then stress wave model is by the stress wave in three state: separate, contact, impact of clearance joints. Okay, they are most talk about clearance actually in stress wave propagation, talking about clearance. Calculating pipe strength and resistance load to transition load, and stress wave expressed in double exponential function dynamic input. So talking about that, many people are doing research on this addition and on this joining again on this carbon nanotube again, and then very few people studying on the cylinder itself, on the square plate itself. Very few people study on that thick plate. The area is thick plate analysis. Okay, not many people doing this research. You can do this research. Is a potential for master and also for PhD level punya research. Okay. Oh, this is among the problem statement I taken from those abstract. Okay, ability to disrupt, alter, and control higher energy wave without significant damage. Okay. Distribution of micro scale features that throughout the material and structure. Uh, Blasting wave propagation in surrounding infinite medium is solved given unified approach for instant wave. Okay, there are one research doing about blasting, and then thermoelastic problem in thick wall autotrophic hollow cylinder, and then blunt impact. There are researcher doing research on what happened projectile impacted a human, impacted the body, impacted the head. Like say people playing soccer, people playing football, the ball hit the head, the ball come and hit your head, what will happen to your brain? Okay, um, this is people are studying it. Okay, and then formation of carbon nanotube clusters. What the way I'm talking about this, because you may repeat this research, and you repeat their research, you doing your own method. Okay, this is among the area that people have studied, and of course you can study, you can improve their research. Okay, and uh, doing justification for your master and your PhD level. Okay, this is the research objective from previous researchers. They are one to improve mathematical model to analyze stress wave for actually bonded functionally graded cylinders. Okay, so if you can do the mathematical model for this functionally graded material, the same model you can use for material like my steel, composite, and everything. Just modified the mathematical model itself. Okay, predicting large data transverse behavior on monolithic and multi-layer square target to a normal impact of rigid spherical projectile. So the projectile come. What will happen when the projectile hitting you, hitting the target? Okay, this is the target, is vertical target. Then you projectile come and hit. Okay, this is the projectile at the transverse location. Okay, this is at the middle part of the structure. What will happen? Okay, this is called large ductile transverse, meaning that this is material is ductile material, not brittle. Brittle like concrete. Okay, like concrete is brittle. Okay, like cement is brittle. But what happened is the steel. Okay, like this. This is a ductile material. Ductile. What happened with if the some projectile hit in the middle of it? What can be the depending the deflection and everything. New approach to avoid the air blast on protective barrier made of sand. Okay, there are researchers doing air blast on protective barrier made of sand. What will happen? Is it the sand will travel away to become also projectile? Maybe. Okay, because use the concept is like this. Air blast. You put the sand here. The sandbag, one bag, sandbag, two bag. Sandbag is all about particle of sand. And then you put significant amount of, let's say, TNT. Significant amount of TNT. And then when it blasting, those sand will project, travel at speed. And then this speed of sand, each individual sand may damage human being. Okay, may damage human being. So if a human being sit at the some certain distance, he will get harm, injury, fatal injury. We do not know. That is what there is research, potential research on that. Okay, propagation of stress wave through material and to quality assess the effect of included rays of geometrical structure and geometrical discontinuity and involves transient heat and stress wave of polymer sandwich plates. Okay, sandwich plate, not to be confused that sandwich that you eat. No, sandwich plate like the same concept as sandwich that you eat. Okay, you put three material. Okay, three material. This is another material. This is a sandwich. The same principle that the sandwich that you eat. Okay, this material A, this material A, and this is material B. Okay, how can it be connected together? This is among people doing research. Maybe you have the idea to do that your own research doing this. Okay, and this is expected result. Joint morphology of expected result is taken from all those abstract I've taken. Okay, some of it have find out that non-linearity of joint stress rate curve in loading section increase with joint contact area. Lateral wave driven by internal energy metric have significant relationship with processing parameter. Clearing size initial axial speed have important influence in stress wave propagation. Stress wave will generate with clearance point in contact. Under lower loading speed, elastic stress wave for concrete specimen appear to be observable. Material characteristic in impactor, feasibility use geometric micro scale. Okay, this is among what all those researchers have find out. Okay, I just compile it, and maybe when you are doing your research, you can expect this kind of result happen on your research. Meaning that before you are seriously doing your research, you have some rough idea what will happen, outcome for your research. Uh, Now we're talking about research methodology. I have listed all the many equation, material, testing, experimental. You may not miss a thing because usually student they do not know what to do. Okay, when they are reading the journal, they don't understand. Okay, and they may miss some important equipment, some important machinery, testing, behavior, property. They may miss. Now I have listed most of them. Okay, so you can use this equipment. Again, consult your supervisor. If that equipment, machinery is not available at your institution, ignore it. Okay, if available, do it. Okay, now we see about testing. You use the shock tube test, gas gun impact test, non-destructive testing. Okay, regarding about gas gun impact test, not many research institution in many places this gas gun. Okay, in US they have, in China they have. Okay, in Malaysia don't have. Okay, previously they have a gas gun. Okay, again, you if you have the specialty, go do the research. Okay, this is the model. You 3D lattice model, analytical model, empirical model, stress wave model, and among other things. These are the equation for those who are interested doing simulation and equation. This is things that people have done. Maybe you will improve that same equation. Maybe you will use the same equation, the same simulation. Okay, it depends on you and your creativity in doing your that research. And then the behavior, thermoelastic dynamic behavior of stress wave propagation, deformation, non-wave propagation behavior, solitary wave propagation behavior, and many more. Okay, there are many, but I just listed a few. Properties, they are dynamic mechanical properties, effective material properties, uh, local mechanical properties, and then the crack. If you are doing this kind of research, crack will happen, fracture also happen. This is more things that you may want to study. Okay, crack on concrete, crack on failure initiation, and crack tip. Okay, and then this is the mechanical responsibility, local mechanical critical characteristic, thermo-mechanical coupling, time dependent. Thermo-mechanical, of course, because you are dealing with, if you are doing research using explosion, there are heat involved, and then this is a thermo-mechanical. What will happen when the heat involved? Thermo. Okay. Experiment, they are doing air blast experiment, air blast loading, experiment integration, gas gun, Hopkinson pressure bar, impact experiment. Hopkinson pressure bar is so popular that you cannot miss doing this research. Okay, method, finite element method, finite difference, functional base match free method, left square method. For those who are interested in doing this kind of simulation, you are doing this, you may want to do this method. This is the analysis of wave propagation, full-time force history, microscopic analysis, numerical analysis, static equivalent analysis. And this is all the analysis that you want to do: finite element, microscopic static analysis, static equivalent analysis. This is the particle when you are dealing with research. Let's say doing sand research, particle that involve small particles. Like for the most related example, sand. Okay, uh, and also concrete, because concrete, when it broke away, it become small particle, and this is the hollow spherical peak particle velocity and everything. And they measure evolution, obtain time the evolution, and this is the morphology. Only one mentioned in those 29 journals, and these are the tensile stress cause, tensile failure surface, tensile surface, and this is the deformation. Of course, deformation will happen. You cannot avoid deformation when dealing with projectile impacting a target. Also, explosion impacting a target from blast wave, deformation sure will happen. Okay, so you is related to deformation, fracture, and everything. So about spore strength, material strength, tensile strength. Okay, you may not miss anything if you are following my suggested result This is a bonding for those who want to do addition. Like say this sandwich material, when become impact, it will bond. Okay, bonding because high impact, and also bonding because of extreme heating. Okay, this is what you want to study. Okay, and then this is the prediction. Okay, Mori Tanaka homogeneous scheme. You may want to venture what is the Mori Tanaka, and last time deformation, last that time transverse deformation, maximum deflection, propagation of stress wave through the material. If you have only okay, this material, let's say a plate, and then how stress propagation travel inside it. Okay, is it become diminished? Okay, is it become lower and lower and lower? We don't know. Okay, you want to study about it. And then the graph. Okay, this is the more the graph. If you shadowgraphy using high speed camera, if you really read the journal content, not only the abstract. If you read the journal content, you may see many graph. Okay, mention of graph A, graph B, graph C. They want to plot A, plot B, plot C. You may know. And this is the theories. You may want to study about this theory first. Okay, in your chapter 1. Okay, classic theory of thermoelasticity, linear fracture theory, third order shear deformation theory, uncoupled theory, viscoelastic theory. uh, Equipment, gas gun, high speed imaging, short tube test facility, dynamic load factor, intensity factor. And this is all the material. There are many more. Okay, I put in the article in the end of the video. And this is the material that have been studied: solid material, carbon, nanotube, composite fiber. If you want to do master and PhD, you may want to do material, different material than this I have mentioned here. Okay, I may suggest like that lah. Of course, you can use the same material also. The list of this material, list of equipment is many. I put in that article. I put in the full article. I don't put in this video. This is the list of related abstract that I have do the analysis. I only put 4. There are many more. 29 articles. If you can acquire the full document at in PDF at the description in this video, in this YouTube video. Okay, so serious student who want to know more, who want to do your master, do your PhD, you may want to access, get the full document at the link below. Okay, so I wish you good luck, wish you the best. Hopefully you can, it is easy to do your master PhD. Just remember, doing master and doing PhD is not that easy, but it also not that hard. Just you have to know the techniques, and this video and the article relate with it may help you a lot in doing your decision, what you want to do, using what equipment, what theory, what anything. So I wish you all the best. Thank you very much.